When looking at chemical calculations, the first thing that we need to know is what our equations are that we can use. So we have three different equations that we can use. We have N equals M over MR. So N is the number of moles, M is the mass, MR is the molecular mass. We have C equals N over V, where C is concentration, N is number of moles, and V is volume. And then we have N equals V over 24, where N is number of moles, V is volume, and 24 is a standard in decimeters. So, with these three equations, obviously we need to know what each symbol stands for and its units. So number of moles is always measured in moles. Mass is always measured in grams, and molecular mass is always grams per mole. So we say to the -1. Concentration is always measured in moles per decimeter cubed. Number of moles is always measured in moles, and then volume is always measured in decimeters cubed. And then our number of moles here is also moles, and then our volume over here is decimeters cubed. So besides having all three of our equations, we also have something called the mole ratio, where I have equations, and every equation that's balanced tells me a number of moles. So that number that you use to balance with is actually important. So here, this equation is balanced. So what that means is there's 1 mole of that, and 1 mole of that will make 1 mole of that, and 1 mole of that. So the ratio of all of these is 1 to 1. So if I look at another equation, I've got an equation that's not balanced. So the first thing I have to do is balance the equation. So I've got 2 carbons over here. So I need 2 carbons over there. I have 6 hydrogens over there. So I need 3 over here because 3 times 2 makes 6. And then I can add up the oxygens on this side. 2 times 2 is 4, plus 3 is 7. So on this side I can say that is 7 over 2 because oxygen is diatomic, so we can have a half. So now I've got different numbers. This is the same as saying 1. So now I have a ratio of 1 to 7 over 2 to 2 to 3. So it means for every 1 mole of this I make, or I use, I make 3 moles of that. For every 1 mole of that I use, I make 2 moles of that. So the ratio, that would be 1 to 2, or 1 to 3. And that we can use to be able to calculate anything. So as soon as I have the number of moles of one thing, I can use it to calculate any of the variables that I have running through any of these, because numbers of moles over here, and over here are common throughout the entire thing. So I can use one number of moles to calculate another one if I have an equation. So if we look at an example of that, I have an equation of sulfuric acid and sodium hydroxide making sodium sulfate and water. So the first thing I need to do is check if this equation is balanced, and it's not, because I have 2 sodiums over there, so that means I need 2 over there, and I have 2 hydrogens plus 2 hydrogens means I got 4, so I'd need at least a 2 there. And if we look at that, then everything in there is now balanced. So now I have a balanced equation with a ratio of 1 to 2 to 1 to 2. And my question says, in a titration of 2 moles per decimeter of sulfuric acid, a volume of 43 centimeters cubed was used to neutralize 25 centimeters cubed of sodium hydroxide. They want to know what's the concentration of sodium hydroxide. So in this question, I have a concentration of sulfuric acid, and I have a volume of sulfuric acid, and I have a volume of sodium hydroxide, and I have the equation. So the first thing I can do, looking through all of my equations, I have a concentration and a volume of one thing. So I have C and I have V, which means I can find N. So if I use that equation, N is going to be C times V. So C is 2 moles per decimeter, and the volume is 43 centimeters cubed. But I told you the volume must always be in decimeters. So what I'm going to do is I'm going to take that volume of 43 and divide it by 1,000 to get to decimeters. And when you type that into a calculator, you'll get an answer of 0.086 moles. So now I have a number of moles of the sulfuric acid. So I know sulfuric acid to sodium hydroxide is in the ratio of 1 to 2. So this number of moles represents the 1. So now I used double the amount for the sodium hydroxide because it's 1 to 2. So what I'm going to do is I would take this number of moles and multiply it by 2 because of the ratio. Because the ratio is 1 to 2, I'm going to say 0.086 times 2 to give me an answer of 0.172 moles for the sodium hydroxide because of my equation ratio. So now I have the number of moles of the sodium hydroxide and I was given the volume. So now I can use my equation because I have C equals N over V. So I can find that the concentration is going to be the number of moles over the volume, and the number of moles is 0.172, and the volume was 25 centimeters, must be converted to decimeters. So I divide by 1,000. And if you type that in your calculator, you get an overall answer of 6.88 moles per decimeter cubed. So that's how we can use everything that we know for our equations and our mole ratio to find the answer of something. So if we look at another example of our questions, here I am given a sample of fertilizer with a concentration, with an amount of ammonium sulfate and sand. There's a 2.69 gram sample of the solid fertilizer heated with 40 centimeters cubed of sodium hydroxide, which is an excess, and all of the ammonia produced was boiled away. After it cooled, the remaining sodium hydroxide was exactly neutralized by 29.5 centimeters cubed of a 2 mole HCl. In a separate experiment, 40 centimeters cubed of original NaOH was exactly neutralized by 39.2 centimeters cubed of a 2 mole HCl. So the first thing they ask us to do is write balanced equations for the following reactions. So NaOH with HCl, so NaOH plus HCl will give me a salt of NaCl plus water, because we always know acid plus base makes salt plus water. And then an NH42SO4 and NaOH, so NH42SO4 plus NaOH is going to give me a salt, because we've got an acid and base in. So the salt is going to be the Na and the SO4. So that's going to be Na2SO4, because Na is in group 1, so its valency is 1, and SO4 has its own valency of 2. So when we cross multiply, we get Na2SO4 plus, because we have ammonium, we will get ammonia. So plus NH3 plus water. Okay, and now we need to balance those equations. So this first one is already balanced. The second one, because we have 2 nitrogens there, we need at least 2 nitrogens there. So we have 2 sodiums there, so we need 2 over there. And then hydrogens, 4 times 2 is 8, plus 2 times 1 is 2, so that's 10. And over here we've already got 2 times 3 is 6. So over here I need 2 more, because 2 times 2 is 4, and 4 plus 6 makes 10. And then the oxygens, there's 4, 5, 6, and there's 4, 5, 6. So now we have a balanced equation. So now we need to calculate the amount in moles of the NaOH present in the 40 centimeters cubed of the original NaOH that was neutralized by 39.2 of the 2 mole HCl. So I have the volume and the concentration of the HCl. So I already know with my equations, that means that I can calculate number of moles. So the number of moles of the HCl is going to be concentration times volume, which is 2 times 39.2 divided by 1,000, because it's in centimeters cubed and I need decimeters cubed. So I will get an answer of 0.0784 moles. And now the question is asking us for the amount of moles of the NaOH. So I know if this is HCl, I have the equation, and HCl to NaOH is 1 to 1. So my ratio is 1 to 1, which means that I have the same number of moles of NaOH. So the NaOH is going to be 0.0784 moles. So now I've got my moles of the original NaOH. Then the next question says, calculate the amount in moles of NaOH present in the 40 centimeters cubed of NaOH that remained after boiling the ammonium sulfate. So if I look at my information that I'm given, so it says, after cooling, the remaining NaOH was exactly neutralized by 29.5 of the 2 mole HCl. So just like before, I can calculate the HCl and use the ratio, because my number of moles is C over V. So this concentration was 2 and the volume was 29.5 over 1,000. So it gives me a number of moles of 0.059 moles. And just like before, I can use the ratio of 1 to 1. So the number of moles of NaOH is exactly the same. So then, it says use your answers to 2 and 3 to calculate the amount of moles of NaOH that reacted with the ammonium sulfate. So this is telling me the original that I had, and this is telling me the amount that was left over afterwards. So the amount that reacted with the ammonium sulfate would be the original minus the amount left after. So I can say my original of 0.0784 moles minus the 0.059 moles to give me an answer of 0.0194 moles. Because we want to always take the original that we had, that then reacted with the ammonium sulfate, and then what was left over was then reacted with the hydrochloric acid. So the difference between them must be what reacted with the ammonium sulfate. So if I look at the next question there, it now says, use your answers in 1 and 4 to calculate the amount in moles of the ammonium sulfate that reacted with the NaOH. So if I look, question 1 was the equations, and 4 was the moles of the sodium hydroxide. So I have the moles of sodium hydroxide, and I have the equation of sodium hydroxide to ammonium sulfate. So that is in a ratio of 1 to 2. So I can take this moles, and I can use my ratio of 1 to 2, okay, and this sodium hydroxide moles represents 2. So in order to get just the 1, I would need to divide it in half, because this represents 2 and I want just 1. So I can say the 0.0194 divided by 2 to give me my moles of 9.7 times 10 to the minus 3 moles. Then it says, hence calculate the mass of the ammonium sulfate. So now I have the moles, and I have the equation in terms of the formula. So because I have that formula and I have a periodic table, I can calculate the molecular mass. So I can use my equation N equals M over Mr, and I want mass. So then M is going to be N times Mr. The number of moles I just worked out as 9.7 times 10 to the minus 3. And the molecular mass I calculate from my periodic table, and I should get an answer of 132.1. So when I type that into my calculator, I get a mass of 1.2814. And then it says, use that answer to calculate the percentage by mass of the ammonium sulfate present in the fertilizer. So this is the grams of the ammonium sulfate. And I was told in the original question, I had a 2.94 gram sample that I was dealing with. So the original gram of just the ammonium sulfate of 1.2814, if I take that and divide it by the total of 2.96 grams, and to turn it into percentage, I'll say times 100 over 1, I will end up with a percentage of 43.3%. So that's just an example of how we can use all of our different equations and our mole ratios to be able to find anything we want.